So here's something interesting to think about, to note. So smart contract languages like Solidity, they cannot be executed by the EVM directly. So what actually happens is when we compile our smart contracts, they are compiled to low level machine instructions called opcodes. And we can see here examples of opcodes. And opcodes are just the instructions. It's a lower level language. It's just what we break down to work with bytes. Because remember, computers work in bytes. And we see we have opcodes to add, to multiply, subtract, divide. In fact, if you go to, let's see so you can see it a bit better. If you go to EtherVM, so Ethereum Virtual Machine.io, you can actually read up on the Ethereum Virtual Machine opcodes. And this site actually acts as an excellent reference to understand, well, what's going on behind the hood here when we write these smart contracts, all right? So we can see that the Ethereum VM is stack-based. The smart contracts are just like regular accounts, except they run EVM bytecode, all right, when receiving a transaction, and that allows them to perform calculations and further transactions. So like we said, the smart contracts act like accounts, but then they do run EVM bytecode. And contract execution starts at the beginning of the bytecode, and each opcode is encoded as 1 byte. All right, except for the push opcodes, which take an immediate value. And if you want to take a look, you can scroll down. We see we also have memory and storage as we're going down here. And memory and storage in Solidity is very interesting because of how it works on the opcode level. And contract storage is something which we are going to dive deep into in this course. So if you're unsure about how memory and persistence works in applications, in coding and virtual machines, and this is something that is important for us to understand and we'll be diving into. So if we keep going down, we get to our opcodes, and here we have the mnemonics, we have our stack inputs, and we can see examples. So if we want to add, for example, the mnemonic of add, we have a uint8 of 0, 1, we have a stack input of A and B, and we can see an output, which would make sense, right? Would be A plus B. If we want to multiply, we have A times B, A minus B, and then there are notes. So if you're curious on what's going on under the hood, now you don't need to learn opcodes to build this NFT marketplace, and we will not be doing that. If you want to learn how to directly manipulate opcodes and work with lower level language on a deeper level, then you will learn that in my complete Solidity course, Zero to Expert. Here our main focus is to learn as much details and tools that we need to be employable, as well as to build our marketplace. And knowing the inner workings of opcodes is not necessary. However, being introduced to it and understanding its place and its role is valuable, is very valuable, and worth the stop and worth the pit stop, in my opinion.